Recently, I had a conversation with an acquaintance, and they asked me what I do, and I think I said I'm actually on a sabbatical, if you think about it, because I'm spending a lot of time at Stanford now, and Berkeley to some extent, but mainly Stanford. I'm attending lots of events, seminars, lectures, symposiums. I'm going to talk about this, and I think I'm going to start talking about those events. This particular episode is going to be a recap from last week, and I hope this is going to be a tradition now, at least for the next couple of months, as long as I'm doing this, because I think it's useful to understand why I'm doing this and what's there to learn. It's unusual. Most people attend these types of events either as students or as professors. Not too many industry people are in those events, and I'm actually surprised because the learning is incredibly useful. So what I'm going to do in this particular episode is recap the week. I try to focus on really what's interesting, who I met, conversations I had, and of course, things I've learned. Just before I even start, let me say that this week, I think the most interesting situation was definitely meeting Onur Mutlu in person, and also the BARS Symposium, the Bay Area Robotics Symposium, which in my opinion is the cutting edge of robotics, which is absolutely key to our investments. We are investing in real world AI, which in other words is robotics. So those were the two main events. I had the chance to talk to Malik, a great opportunity also. And this already reveals a lot of the reasons why I'm doing this. I mean, look, living in Los Altos, 10 minutes from Stanford is a privilege, and taking advantage of Stanford is a huge privilege. It's definitely a very top-notch university, not necessarily in terms of professors and students, they're all top-notch too, but what's really amazing about Stanford is the cloud, the kind of people it attracts, the industry, the professors, the symposiums, all of that stuff. It's really, really exciting. So I think the purpose of this podcast series, Not Even Wrong podcast series, is to give people a sense of what it feels like to run a hedge fund. And we're in the knowledge business. So acquiring knowledge, having conversations with people who are at the cutting edge of their industries is really part of the business. This is the Not Even Wrong podcast. It's October 27, 2023. This is Krim Delco. Since the last update, we're down roughly 5%. The market's down 2%. For the year, we are up 76.5%. The market is up 7.2%. We're outperforming by 69.3%. Before I go into the conversation of today's episode, in general, the markets are jittery because of the Middle East conflict, high oil prices, and high interest rates. We are in a macro situation that, in my opinion, is very fragile. The good news is that we can get government to stop spending money. I think we have a new Speaker of the House, which will definitely move us into that direction. And then we have the problem with the Middle East, which of course is unpredictable and unfortunate. And hopefully also there we will get more streamlining of the situation in terms of incentivizing all the parties to find a solution. Now let's talk about last week. We started Monday, the October 23rd. We did a cosmology seminar, which is basically the way cosmology works is it's trying to find signal in the noise of data, massive data sets from cosmological observations. And what's really interesting here is the techniques that are being used to find structure in the data. Now, the goal in this particular seminar series is to build models that trace back to the Big Bang, to the primordial Gaussian, to primordial non-Gaussians. In other words, we have the Big Bang, and then we have certain quantum fluctuations which start moving the soup or whatever that thing was after the Big Bang into unstructured relationships, and then inflation kicks in, or dark energy, and starts expanding the universe, and then we have this huge complexity that we have today. So what cosmologists are trying to do is try to sort of reverse engineer that from what we see today, go all the way back and try to find models, try to build models. So you can argue about the usefulness of this, but one thing is clear: these people have enormous use in data analysis, data science, and AI, because their techniques are definitely transferable. So next thing we did is the AI seminar on digital economy. Now, this is an interesting situation. This is the HAI, the Human AI, Human-Centered AI, Artificial Intelligence Center at Stanford, and they have a subsection called the Digital Economy Lab. I attended a lecture by Malik. He's a professor at Wharton Business School, and he was talking about sort of the first research that he's done, or early research, in terms of how generative AI triggers different productivity dynamics in the workplace. I think the most interesting takeaway here was that it levels the playing field. So lower performing agents, lower performing workers in different workspaces. In this particular case, we're actually talking about Boston Consulting Group. So they did an experiment at Boston Consulting Group where they studied different types of performers, and they found that the lower performers take a lot more advantage of ChatGPT than the higher performers. In other words, there's a level playing field. And I think this has huge repercussions on the way we're going to think about productivity, hiring, about all kinds of things. So this is, one of those examples, I think, where, we have to take this pretty seriously. We have to take this seriously. And I think I was really inspired by this talk. I also spoke with Ethan afterwards about this, and he doesn't have, he's I would say, not a very straightforward type of person. He's a summarizer. He is good at telling you what's out there and what kind of research is going on. But he doesn't have a sort of a vision. He doesn't have a structured, logical explanation for things. So he's not Deutschian in that sense. He's not too keen on explanations. He's more keen on revealing data, which is fine. I think another interesting seminar I attended that Monday was the chemical engineering seminar. Now, here I attended, it was about fluids, and it was about creating engineering fluids that can be used for haptic signals. And I'm gonna get back to this because today, actually on Friday, I attended a robotics symposium here, and touch is a underrated, hugely important sensor for robotics. This is key. This is really, really important. Touch is an underrated, highly important sensor for robotics. And this chemical engineering seminar actually helped me understand that, because that's one of the things that they're doing there, trying to build fluids, trying to build technology that helps create better touch sensitivity. So I think this is definitely well, how should I say? This is an area where I'm going to pay a little bit more attention, because again, in the robotics seminar, I realized how important touch is, and I'm going to get back to this. Actually, I'm going to get back to this. And next day, on Tuesday, we have the Signature Fall Conference, Generative AI, and how it affects humans, how it affects work, and all kinds of things like that. I think the most interesting presentation there was definitely the presentation about a group from DeepMind, and what they're trying to do is try to understand machine knowledge. So what the lady explained is that we have, when we train a machine, let's say a chess machine, Go machine in case of DeepMind, but any kind of robot or anything like that, there's a certain amount of knowledge, let's call it M, and H, or whatever, it doesn't matter. Let's say there's a big bubble, that's the knowledge, And then there's a certain smaller bubble, that's where human knowledge, so that's the stuff we understand about knowledge. And there's a big part that we don't understand. And this lady is trying to understand this with certain techniques. Now, how they do it, that's a lot of these types of presentations, they become technical for good reasons, because they also want to advertise their work, their research. They sometimes want to get tenure at a university and things like that. But what's important for us is that there's a problem, there's a question, there are potential answers. The big thing that I take away from these human AI type conferences is that the more we think about AI, the more we learn about humans. In this case, for example, what does it mean to be creative? What does it actually mean when a machine does something that we don't understand? Does that mean the machine is smarter than us? Or my takeaway in particular, in this particular case, because they spoke about a chess playing machine, and they kind of, their argument was this machine is superhuman because it beats all the humans. But then there was actually a chess player present. She presented with the research lady from DeepMind, and the chess player said, look, a lot of the stuff that we do as chess players is also constraining us, in a sense that we have energy constraints, we sleep, we get tired, we make mistakes. The machine doesn't do that. So a lot of the winning, a lot of the that so-called superhuman knowledge is more based on the fact that the machine actually doesn't get tired and things like that. Now, my interpretation is the following, that, look, it's not a surprise that a machine is superhuman, because the machine can iterate billions and billions of moves and store those in some sort of memory. We can't do that because we can't iterate that much. So that's, I would say, the most interesting takeaway of that particular conference. There were other presentations. I think the conference is a lot more interesting than you might actually think, maybe on first sight, because a lot of the stuff is what my partner calls fluffy, in a sense. We talk about, of course, we talk about bias of AI and racism and things like that. Those are important questions, though. It might sound fluffy in a sense, look, it's not hardcore robotics where you solve hardcore problems, but you solve societal problems. And really, the most interesting thing about AI for me personally, or maybe something other than the potential to solve problems and create wealth, is that it also opens up questions for us, for humans, for society, and I think that's really key. I think that's something that we shouldn't underestimate. Anjo Kanazawa, professor at Berkeley, presented her ideas about Nerfs and Nerf Studio, something that I also saw a lot at the robotics conference. So what Anjo is doing is really create sort of an open source framework for taking advantage of Nerfs, and Nerfs, a technology that allows rendering of camera pictures. So what you do is you take pictures with a camera, which is, you capture photons, and you train a neural net to take those pixels that it reads from the camera and reconstruct the picture, and does it in a really nice way. Nerves are very popular, and in robotics they're particularly popular because they allow for depth. So Anjo was talking about the opportunities there. Definitely an interesting person also, but I think also not but interesting also how Berkeley is doing an open source project here and trying to really enable other people to take advantage of Nerfs. Eric Björnolfsson, the head of the Digital Economy Lab, or Digital Economy Lab, yeah, that's the name. He spoke about his research, which again goes towards, okay, how is Gen AI affecting the workplace? And I think, again, key takeaway is the fact that it's leveling the playing field, which in my opinion is just, it might be obvious for some people, but not for me. I think it's really, really interesting. Same day, there was the graph learning workshop, something I attended last year. I would say graph learning is an interesting subfield of AI, because it's it's about graph representation of networks and how they take advantage of that type of representation in terms of learning. There's definitely some advantages. But what's interesting here to me is how this field is really losing its lackluster because of Gen AI. And I think there's a nice example of how, social networks in the 2010s became so popular, and graph networks grew with that popularity because graph networks are the natural way to represent social networks. And then let's say there was a person from Amazon actually present at the conference, and he spoke about how Amazon took the graph network representation really seriously and uses it for search and recommendations. And I would say today that's still okay, but you want to switch, you want to pivot to Gen AI, and it seems like to be difficult to do. So I think that was my biggest takeaway from that learn. I only attended one presentation, the Amazon presentation, because I was curious to hear. Basically, a lot of these AI conferences, my first question is, okay, how are you incorporating large language model architecture now into your Lambda version? And I must say at Amazon, this didn't look very good. Next, I did a physics colloquium on Tuesday, every Tuesday. And the physics colloquium was in this week was definitely a huge one because it was about quantum information, about quantum computing. The person that presented, Vladan is a very senior, extremely distinguished atomic physicist. And he presented a system of using certain attributes of atoms, in particular what's called Rydberg states, to create entanglement and use those particular states also for quantum information. I don't want to go too much into detail, but I think the really interesting takeaway from this lecture is that Vuletic is talking about 10 logic cubes already, qubits, and the potential for more. And once we get to 50 to 100 logical qubits, then we are talking about Shor's algorithm already. So there seems to be a development, and interestingly enough, the same day there was an article in Ars Technica about Atom Computer, a company that has a relationship with Vuletic because the person that founded it did his undergrad at MIT and did his PhD at Colorado Boulder, where he actually used Rydberg states for atomic clocks. And what Vuletic said in his presentation is that how you can use Rydberg states for atomic clocks. He also did the presentation next day, actually, in the Q-Farm seminar, where he spoke about how they're using particular technology called spin squeezing to create atomic clocks that are more precise. I think the most interesting thing about this whole physics colloquium this week was definitely the potential for quantum computing is there, it's happening, and we could actually be around the corner here. Now, I've heard this many times before, but I think Vuletic's presentation really gave me sort of a sense that we could be at the cusp of something, maybe not a quantum computer that can, break Shor's algorithm or something like that, but there is a potential for let's say, simulation of nature, material science, all these things. And just want to remind people that at Orange Capital Partners, we started a while ago investing in the decarbonization of the economy. And the more we do this, the more we think about the problem, the more the solution is in compute. Compute across the stack is going to allow for computational methods to solve problems that will allow us to decarbonize the energy. So that's where this quantum computing idea really kicks in, and we're obviously incredibly excited about. Next, in the evening, I did a reading in the English department where we had two really interesting creative writers from the Stanford community. One is a former Wallace Stegner Fellowship participant, Edgar Kunz, and the other is a Stanford grad, Bauhini Vara. She is now an accomplished novelist, actually. Both of them, I would say, definitely interesting as people. It's fascinating to attend those creative writing readings. It's fascinating in many ways. I think most interestingly, of course, It's because you're at Stanford, everything is about robotics and engineering and electrical engineering, and now you have these creative writers. So it's beautiful to have that contrast. I would say Kuntz is a poet, so that was, poetry is challenging but interesting, and it makes you think, okay, what is AI, what is ChatGPT, and what is a human poet? And I think the difference is life. I think the poet's business is to transpire life. That's something GPT will not be able to do. Both of these writers were very good at that, actually. I would say also Vara, she's a very straightforward, no-nonsense woman. Her work is exactly like that. There is spice in there, there's sex in there, there's vomit, there's shit, there's beauty, there's success, there's everything. It's life. And not that I don't think AI can't mimic us on that front, but it's just beautiful to have that type of exposure, and I really appreciate those readings. So highly recommend it. Thursday, I would say that was a big day. I met Onur Mutlu. He talked about the Rowhammer situation that he's obviously very famous for. I don't want to go into details here, but what I want to say about Onur is the following. I think he is an incredibly creative and interesting person that helps me understand the stack and the problem of that data-centric compute. I think there's a correlation between what he's doing and what, let's say, Chris Ray at Stanford ComSci professor and also Andrew Ng are saying. They come from different angles, or not really. They're just in different levels of the stack, if you will. Chris Ray is up in the sort of between application and software level of the stack, and Onur is more sort of in the ISA level of the stack, or even below on the engineering side of things. But what they're both saying is, look, we have to stop this mentality of CPU is the core of a computer and then data is some sort of external adjacency. It's the other way around. It's about the data. Now let's build systems that can read that data and do something useful with it, with low, power budget and other, constraints that are right now becoming a problem, because we're using a lot of power and a lot of the complexity to patch up all the issues that we have, because our traditional fundamental infrastructure that we have that we've had for the last maybe 60, 70 years is not really able to deal with software 2.0 and the data-centric compute paradigm. And this is something that Onur is propagating. So I really appreciate it. And I think this is really the transition now from, or the answer to the question, okay, why are you doing all this? Well, like I said, we believe that compute is going to be the answer to a lot of the problems that we are investing in. That compute is going to be a driver for knowledge, and it's our job to turn knowledge into wealth. So to have a good understanding of what problems compute can attack today, where the problems are going to be tomorrow, and how it's going to be attacked, I think it's just a great way for us to think about the problem. It doesn't make it a slam dunk, but it's definitely the right lens to put on an Onur. I'm very thankful for that. I hope I can have a chat with him. I asked him to go for coffee with me, and we'll see if that works. Now in the evening, Scott Aaronson on Eurocrypto. Look, Scott is an interesting person, but he is also definitely on the sort of don't take him too seriously side. Okay, he's a bit dangerous for people that come from the outside. He used to talk a lot about quantum computing and quantum information. And quite frankly, I think he's very similar to ChatGPT. He resembles, to me, he resembles more of a stochastic parrot than a knowledge person. And for people that come from the outside, it's very dangerous, because he talks like he knows what he's talking about. And I would say more than half of what he's saying is semi-true, or he's just not thought about it too much. So that, in that sense, I have a problem with him. But he's entertaining. He's an intellectual. I would say he's more of an intellectual comedian than actually an intellectual. He has a PhD from Berkeley. He's a professor, all of that stuff. Now he's working for OpenAI. That's a whole other conversation Why is OpenAI putting up with a guy like that? And maybe the question should be reversed. Why is a guy like that going to OpenAI, which opens up questions about what OpenAI actually is? And I would say there's a lot of question marks there. Let's leave it at that. So now the big one is today, BARS, Bay Area Robotics Symposium 2023. That's a big one in many ways. I'm going to do a special episode just about some of the learnings that I took away from there. But let me just summarize. I think the key takeaways are that there's a lot of work in how to use large language model architecture and implement it in robotics. Nerfs are a big deal in terms of using them for depth and for perception and all the other adjacencies that come with that. You know, Tesla's doing already. They're using Nerfs and occupancy networks to manage navigation. I had the chance to talk to Matindra Malik, and I might be butchering his first name. I'm really sorry about that. But he's a big, I would say it's Jitendra Malik. I apologize, Jitendra Malik. So I asked him, are we playing in the wrong sandbox here as roboticists? Shouldn't we just focus on simulation, solve simulation? And he kind of said, look, it's a valid argument. He said, I'm too old to switch, which comes interesting because he said in an interview with Peter Beal, he said that he actually switched at least 2 times in his life. He went from electrical engineering and deterministic differential equations to neural nets, and then within neural nets he made a switch. I forgot exactly where. Now he's working on dexterity problems, which I think is the most interesting part of robotics, which kudos to him, is really where I think sort of the juice is, because once we solve dexterity, I think we can have a lot of transfer learning for other robots. And the question is, should we do it sort of the traditional way with try and error in the real world, or shouldn't we just work on a simulation and then do self-learning a la AlphaGo Zero, and then after a billion iterations use the weights from that learning at least as sort of a transformer style pre-learning, and then we can learn more. Again, I'm going to talk more about BARS in a separate episode, but other than meeting Jitendra Malik, I also had the chance to attend a lecture by Sergey Levin, another Berkeley roboticist, pretty I think influential and interesting. Lots of students, lots of I met Wave, a company that does end-to-end self-driving. I met Gatik, a company that does also self-driving. Then there were NVIDIA was there. Didn't talk to them specifically. Again, I'm going to do a special app, but this is definitely one of the big ones. Kind of fell from almost out of nowhere. It wasn't really on my radar, but I happened to have a chance to attend it, and it was incredibly inspiring, particularly also because obviously we're interested in that space from the compute side and also from the application side. To summarize, this week was incredibly prolific. We had huge events, Human AI conference, BARS, the robotics conference. The graph learning workshop was more of a sort of dud, I would say. Then the physics presentation by Vladan really opened my eyes again for quantum computing. Take it seriously. And then meeting Onur Mutlu, of course, and having a chance to talk to Jitendra Malik. Those were the 2 highlights of the week. Thank you.